Okay, vocal check 1, 2, we're rolling. Thank you. The session is being recorded and will be posted later on the recorded presentations page of this class's page and my TCC Blackboard. Hello, synchronous attendees and asynchronous attendees who may be watching this later at their own convenience at a later time. Here's what we're going to cover today. Today's Tuesday, January 26th. It's just after 9 o'clock. And I'm going to cover the Module 3, which covers VLANs and trunking concepts. The first PowerPoint I'm going to cover is the one that's in the presentations page entitled Intro to VLANs and Trunks. And then I'll cover the last part. It's an older one, but I like the graphics on it better. I think it has good graphics. And the second PowerPoint is the actual official Module 3 one. I'm going to cover the last part of that. And then on Thursday, we'll have our in-person lab opportunity, or you can stay home and you can do it on Packet Tracer Lab 3.4.6. And Thursday morning, I'll record that on the actual real Cisco equipment, and on Packet Tracer, it's going to be performed pretty much exactly in the same sort of way. Now, hang with us a second. I'm going to go here, and I'm going to share a Packet Tracer screen for just a second. Oh, I need to share the entire screen. And here we go. So normally in Packet Tracer, this is kind of like the first lab that we did. If I go to this first PC here, oh, let me actually put it over. There we go. Now you can see my mouse. So if I go to this first PC here, and if we float on the thing, if we float on it, it'll tell us that, oh, this first PC is 192.168.1.10, and the second PC is 192.168.10.11, and we have two switches that are not configured at all. So we can see that by default, all the VLANs, all the ports are assigned to VLAN number 1, the default VLAN. So I should be able to ping these devices one to the other. So I'll go to PCB, and I'll go to the command prompt. Just expand it a little bit so it can be viewed. So if I type ipconfig here in this sort of fake Windows environment that they give us, he tells us that my IP address is 192.168.10.11, and I should be able to ping the 192.168.10.10. The other PC, I can ping it just fine. Okay, so that's the way that switches come from the factory. Everything's assigned to one broadcast domain. Everything connects by default to everything else. But in any larger type of medium to large size company, we're probably going to create different VLANs, which are like broadcast domains, to be with different departments. Okay, hang loose. Attendance here. Okay, so now I'm going to go and we'll start the actual death by PowerPoint now. Okay, I'm going to bring my mouse down to the right section here. Stop sharing this. And I want to share the first set of files. So I'm going to use this first one. There we go. So here's the dictionary definition. What is a virtual local area network? It's a isolated network. It segments. It isolates segments based upon. It can be based upon your function of the employee, what project team they're on, what application they're on. It's typically done by department. Well, so that may be the marketing department, which has their secret marketing plan for the company that's so secret that not even the other employees should be able to look at it, so they can put them on their own security isolated network. Or maybe an engineering lab or research department, production department, advertising department, sales departments, executive departments. All these things can be placed in separate broadcast domains. So, and now in a later chapter, since they're in separate broadcast domains, remember that routers separate broadcast domains and connect them together. So if we create VLANs on switches, it does create separate broadcast domains, but they're not connected together. So in the next chapter, we're going to look at bringing in a router into the picture and restoring the connectivity so the different departments can actually talk to each other. So what's going on a switch by default? So here's a picture of the switch. And if you look at this command show VLAN on the switch, he shows us all 24 of the fast Ethernet ports, and 2 of the gigabit ports, the ones on the ends, are all connected to the same VLAN. This means that any one of them, whatever Ethernet traffic they send into their port number, it will be available on all the other port numbers. They will be able to have communication with each other. I was able to ping my PCA and my PCB. They're all connected to the same VLAN. The two switches were connected together. So that's what they come out of the box. Now, remember that about 75% of these Cisco switches that ship into business, ship into the world, are never configured. They just want them, they go into a business where they just want to plug things together and everybody can talk to everybody else. They buy one or two switches, they plug them all together, and they get communication. And no, they don't have to hire a Cisco guy for $300 an hour to come in and configure them for them. But in larger corporations, you want to isolate this traffic. You want to increase the performance of the network. So let's plug some host machines into these switches and see what we get. So the hosts are all configured to be 192.168.10. Some number, he's using 10, 11, 12, and 13, and they're plugged into 4 ports on this switch. So the hosts can all communicate with each other because there's a physical need. They have to be plugged together into the same switch, so they're physically plugged together. And the switch ports are all by default configured to be on the same VLAN. That's VLAN number 1. That's the default VLAN. We haven't changed anything yet. So logically, the 4 hosts A, B, C, and D, they're configured to be on the same subnet. They're all on the 192.168.10. The bold number is the network prefix. The lighter number is the network identity, host identity on that individual network, so that they can all ping each other. So for example, if A did an ARP broadcast request, if this machine, he tried to ping another machine and it wasn't in his ARP cache, he would send out under the hood, you don't do it yourself, under the hood, the TCP/IP code on workstation host A would send out the broadcast request, which is essentially calling all stations, broadcast this to everybody. If your IP address is 192.168.10.13, let's say A is trying to ping D, then would you please send me back your MAC address? Because in order to ping you, or any other traffic with you for that matter, I have to know your MAC address. And then workstation D, if he was the one that was trying to communicate with, he would respond with an ARP reply saying, yeah, I'm 192.168.10.13, and this is my MAC address. And now A can then put whatever traffic he was intending to send to D in that completed Ethernet frame with the actual address. So the question here is, can A, B, C, and D ping each other? Well, absolutely, yes, they can all ping each other. They might have to do an ARP request first and get a reply, and the first ping might quit. The first ping might time out. But yes, they're absolutely going to have communication with each other. Now the last question, if A did an ARP request for B, and of course an ARP request is a broadcast. It's a broadcast because I don't know your MAC address yet. I can't make it a unicast. To make it a unicast, I have to know your MAC address. I know my own MAC address. It's burned into my NIC card. I don't know your MAC address. I used to know it, but I forgot it, or I've never known it. So I need to do an ARP request first. So broadcast, the most common source of broadcast in networks is ARP requests, which a sprinkling of those occur throughout every day. And then when they turn on in the morning and they do that DHCP broadcast to learn their IP address from the IP address server, the DHCP server, that's in the form of a broadcast. That has to be a broadcast as well because they don't even know their own numbers yet. So if A did an ARP request for B, who would see this Ethernet broadcast? Well, what's the default response of a switch whenever he receives a broadcast from that port that A is plugged into? If a broadcast flows into that port, who hears it? Who sees that? And the answer is on a switch with default configuration, which so far this is, everybody would hear it. So host B, C, and D would all hear this broadcast. Now it's an ARP request for D, and the D is the only one that respond to it, but they'll all hear it. Now when we start chopping this switch into like separate VLANs, only the people in your individual VLANs will hear your broadcasts. So VLANs create smaller broadcast domains and improve the performance of the network. So a VLAN is a logical partition. And let's imagine if we took a fireman's hose and chopped this switch into 2 pieces, of the red piece and the blue piece. It's like 2 separate switches now. They just happen to be in the same box and share the same power cord. So we're logically going to partition, which normally would be this 1 layer 2 dead link layer Ethernet dead link layer switch that this switch is composing. So I can create as many partitions as that. Well, there's a limit of about 1,000. I can create multiple partitions and allow multiple VLANs to coexist on this switch. So every individual VLAN on this switch, the blue ports 1 through 12, they're their own broadcast domain. usually corresponding to their own IP network. For example, we might make VLAN 10, and the IP addresses would be 192.168.10. something. The red ports 13 through 24 on our switch, they're their own network. Now, suppose that that workstation A that was plugged into the blue port did an ARP request, and that's a broadcast. Who hears that broadcast? Only the other ports that are in blue. They've been configured to be on their own VLAN. The ports in red would not hear them. So there's no communication right now at all between any blue host and any red host. It's like it's two separate switches that are not tied together. To get them to communicate with each other, we'd have to put a router in there and have the router configured to go back and forth between the two devices. We'll do that in the next chapter. We're just going to do VLANs today. So the VLANs they're isolated. They're their own broadcast domain, usually IO and IP network. They're isolated from each other. Packets can only pass between them if we put a router in there. So the partitioning, this takes place inside the switch. Now the old hubs couldn't do this. The hubs were dumb. The hubs are dumb. Don't be in the hub club. Be a member of the switch club. Switches are smart. So we go into the iOS configuration commands for the switch. On Cisco switches, we can do that. Other manufacturer switches may have a menu that does it. So the hosts, now here's an important concept. The hosts that are plugged with all those hosts that are plugged into the blue ports, they don't know anything about VLANs. So far as they're concerned, they're plugged into a separate switch. And all the hosts on the red, all the hosts that are plugged into the red ports, they just think it's a second switch. And they can't hear the blue switch because we haven't connected it together with a router yet. So if we have a single VLANs, if all the ports had not been configured yet and it was no VLANs, really everything's a member of VLAN 1, well, we've configured hosts A and B to be on the .10 network. They'll be able to ping each other. We've configured host C and D to be a member of the .20 network. They'll be able to ping each other. Now, the blue host won't be able to ping the red host, but that's just because they're not. You have to configure two host machines to be on the same subnetwork, even if they're plugged into a hub or plugged directly with a cable. But they won't be able to communicate with each other unless they're configured on unless they're configured to be on the same network. So A can ping B and B can ping A, C can ping D and D can ping C. So with a single VLAN, there's no segmentation. So if host A is trying to ping host B, he's going to send a broadcast into the switch, and the switch still has the default factory configuration right now. So the ARP broadcast is going to flow into the port, and it's going to go out all the other ports that have devices plugged into them. Now they're going to hear them. Post C and D will hear it, but they're going to ignore it because it's wasted bandwidth. They're not on that network. They're not going to respond to it. So if A did an ARP request for B, A can ping B and B can ping A. A cannot ping C, A cannot ping D, C and D can ping each other. So if A did an ARP request for B, everyone would hear it, but it would only be ignored except by the B host because he's on the same subnetwork. If C did an ARP request for D, well, D would hear it, A and B would hear it, but they would ignore it. So you have to be on the same subnet, but we're wasting a lot of bandwidth. Okay, so let's go to the switches and configure our VLANs. We're going to configure this on a per port basis. In this case, using some mysterious commands we have not yet learned, all the ports 1 through 12 have been configured to be in one VLAN. I'll just say VLAN 10, for example. All the ports in the red, outlined in red, have been configured to be on a second VLAN, maybe VLAN 20. And then we're going to configure IP addresses and subnet masks on those host machines, on those devices that plug into those switch ports. So we actually do it on a port-by-port basis. Now, you remember that first lab that had a thing called interface range, and you configured all the ports on the switch to be in members of VLAN 99. You didn't have to do 26 commands. This comes in handy also when we do VLANs. We could use interface range 1 through 12, and then use the command we haven't learned yet to configure them to be a member of VLAN 10 or VLAN 20 or whatever. So VLANs are configured on the switch port. So in this case, he's configured ports 1 through 10 to be on the blue VLAN, and we're going to call that VLAN 10. He's configured ports 13 through 22, 13 through 24 to be on VLAN 20. Those are the ones outlined in red. And they've been configured on the switch port. And we'll see the command for that in just a second. And then we're going to configure IP addresses. Now notice that, let me turn on my little pencil here, VLAN 10, and the third octet of the IP address is 10. Just, it makes it a little easier to keep it straight in your head when you use some consistency there. So it's very common that the third octet of the IP address is the same as the VLAN ID. So the ports that are configured to be in VLAN 20, we're going to logically configure those machines to be, the third octet of the IP address will be 20. Now they're physically isolated now. We've configured the ports, but we haven't seen the command yet. We'll see that shortly. And he's left a couple of ports free here. That's because later on we're going to use those for Cisco IP telephones. And they're going to have a different configuration. So he's left those as spares. So before, everybody was on the same VLAN. We're outlined in blue here. Everybody's in the default VLAN. VLAN number 1 is the default VLAN. So all the IP addresses of all the 4 host machines were configured to be a consistent IP address where they could talk to each other. That's the default configuration for a small company. After configuration, well, let's say this company has decided that they want to split the advertising department and the marketing department into 2 separate for security and performance of the network. So after these proper commands have been issued, ports 1 through 12 and that first gigabit port are in VLAN 10. And they all have .10 as the third octet of their IP address. All the host machines that are configured to be in ports that are configured for VLAN 20, they have 20 as the third octet of their IP address. This would be after configuration. So when we do this new command show VLAN, it shows us that now, remember before, they were all in the number 1 VLAN. By default, that's what they are. But now we've reconfigured the switch. So half the ports are in VLAN 10, half the ports are in VLAN 20. So it's like separate switches. Okay, the fireman's axe has chopped the switch into 2 pieces. The ports that are configured to be in VLAN 10 in blue, it's like it's a separate switch. The ports that are configured to be in VLAN 13 through 24, they've been chopped away. They're separate. It's like a separate box. They're in their own network. They don't hear each other. There is no communication between the blue ports and the red ports. They're in separate VLANs. Later on, we'll put a router in there where we'll store communication between them. So VLANs segment switches to different VLANs, and a VLAN is always going to be corresponding to a subnet, like the .10 for the blue, the .20. It's like having separate switches. So who can A ping? A can ping B. A cannot possibly ping C or D because they're not even physically plugged into the same switch. So if A did an ARP request for B, who would hear the broadcast? Only the blue ports would hear the broadcast. If C did an ARP request for D over here, only the red ports would hear that broadcast. No, normally broadcasts are flooded to all the other ports on the switch, on a default switch, but we've changed the configuration now. So here's what we're going to do later in the next chapter. We're going to do VLAN, inter VLAN routing. We're going to take some ports from the switch and plug them to the router, and then we're going to configure the router to route back and forth within the .10 network and the .20 network. So routers are required to connect or route between subnets or VLANs. So why do we do all this stuff? Well, it could give us security. Maybe the red VLAN is the marketing department and they don't want their secret marketing plan for 2021 to be available to anybody else in the company. So we've increased security of the network. It reduces costs because we can use our existing switches and simply configure the ports that they were needed to be for different departments to go back and forth. You're no longer isolated to, you're no longer constrained to whatever hub you happen to be closest to within 328 feet, you were in that broadcast domain. So we get smaller broadcast domains. This reduces the number of broadcasts, improves the performance of the entire network. And for us people that have to manage the IT stuff, it makes it easier for us to manage. How many VLANs can you configure on a switch? Well, our Cisco 2960 switches, theoretically, they could be over 1,000. But the Cisco 2960 switches are for companies that are small or medium sized. They're limited to about 255 VLANs. Now, that's more than most any company would need. Typically, you'd have 1 or 2 dozen departments, and you would normally need 1 or 2 dozen VLANs in your organization. Now, normal range VLANs, the number it's a 16-bit number. So the normal range of 16 bits would be from 1000 to 4094. Some of them are reserved. The numbers from 1002 to 1005 are reserved for obsolete stuff. Token ring, which hardly anybody uses anymore. Fiber distributed data interface. They are automatic. Now, VLAN number one, an important concept here is VLAN number one is the default VLAN. It's automatically created and present on the switch. It cannot be removed. It cannot be renamed. And you remember when you started on a lab, I told you had to erase that VLAN.dat file if it was present. That means someone else who used that switch before you had created some VLANs and it wasn't the default configuration. And if you didn't delete that and reboot the switch, reload the switch, you would have some inconsistent VLAN definition with what you were doing and it wouldn't work properly. So normal range VLANs we have about 1,000 of them we can use. Extended range VLANs are designed for like a service provider, like an internet service provider. He might have 3,000 customers. He might want a separate broadcast domain for each one of those. So we're going to stick to, at CCNA, we're sticking to the normal range VLANs. CCNP, they'll go to other stuff. Okay, so here's what happens if I go to the switch and type the command show VLAN. So I see all my ports by default are assigned to VLAN number one, the default VLAN. And those 1002, 1003, 1004, 1005, those are there by default. You can't use them, just ignore them. Pay no attention to those. You're going to, in the Cisco network and Academy labs, we're always going to use the VLANs 1, and usually 10, 20, 30, and then 99 for a management VLAN, like we did in the first lab. So this is the default configuration. So in a small or medium-sized business, we're going to use just the thousands, the first 1,000 or so. Now we can't mess with one. We can ignore it. We can move everything off of one. That's considered good security practice. 1002 through 1005. We're just going to pay no attention to those. We're going to go in our labs. We're going to create VLANs 10, 20, 30, 99, something like that. And when we create those, that VLAN.dat file will pop up when you do that dir command or show flash. It'll pop up and you'll see a file VLAN.dat is there in the flash memory. And that's why you have to erase it if you're starting a new lab with a new configuration. You have to do the two things on the switch. You have to delete the VLAN.dat file if it's present, and you have to erase the startup configuration if it's present, and then do the reload on the switch so it'll come back up in the default configuration. Now, there used to be a thing in CCNA called VLAN trunking protocol, which is not in there anymore. It was a means of automatically configuring. If you created a number of VLANs, you wouldn't have to create them over and over again on a bunch of different switches. Think of a Microsoft domain controller where you have multiple domain controllers and you don't have to create your passwords 3 times when you change your password. So that's not in there anymore. It's just a concept. Okay, types of VLANs, default VLAN. By default, this is what the switch is configured as. All ports are assigned to VLAN number 1. Now, they do this all the time. What the heck is untagged traffic? We're going to get that later. When we tag the traffic, we're going to tag the traffic as the Ethernet frame came from VLAN 10 or VLAN 20, so it can be sorted out when it gets to the switch. Now, user VLANs, this is like our VLAN 10, 20, or 30. Maybe 10 is the marketing department. Maybe 10 is the marketing department, and 20 is the engineering department, or something like that. Now, when we did that lab last time, we created the management VLAN. We created VLAN 99. If we're going to have Cisco telephones, we're going to create a voice VLAN. Typically, it's got 100, 150, something like this. Now, what if you want to have access for contractors and visitors that come to your facility, and you don't want to give them access to all your internal resources? You can create a guest VLAN. And the concept of a garbage VLAN is, I'm going to create a VLAN that nobody is ever going to be connected to, and all the ports on the switches that aren't being used, I'm going to assign to that garbage VLAN. So if someone manages to get in the wiring closet and plug into an unused port, they will not get any access to my goodies. They won't get their grubby grimies on my goodies, because whatever port they plug into is unconfigured. Okay, so the VLAN, number one, is our default VLAN. It's native, which means it's untagged. We haven't talked yet about encapsulating the frame so that we can tell what VLAN they're in. The Cisco Discovery protocol, which like show my neighbors, all these other protocols that are listed here are run on the native VLAN. So all traffic is carried across VLAN 1 by default. All 26 ports of our switch are assigned to VLAN 1. So it's the default VLAN. It's the native VLAN. No encapsulation is required because there's only one VLAN. And all our controlled traffic, like VLAN trunking protocol, dynamic desktop trunking protocol, spanning tree protocol, all this, we haven't talked about these things yet, are all associated with VLAN number 1. So VLAN 1 cannot be deleted. It cannot be renamed. It's there by default. So you do show VLAN on an erase switch, you get this. So since it can't be, since you can't do anything with it and we can't delete it, let's just not use it. Security best practices is avoid using VLAN 1. Now the thing we can't mess with is Cisco Discovery Protocol and the other stuff that has to be on VLAN 1. We'll leave that on VLAN 1 because we won't show CDP neighbor to make sure our labs are wired up properly. So let's create some additional VLANs for our user traffic and our management traffic. So let's create here. Okay, here's some mysterious new commands. I'm going to go to the configuration mode, config T, and I'm going to type the command, not the configuration mode, VLAN 10. Okay, remember the switch had no VLANs before. I've created VLAN 10, and I'm going to name it the Human Resource Department, HR. Okay, that's the first part. I got to do two things here. I got to do this first, and then I got to do a second part. I created the VLAN. I did this thing and I created the VLAN. The VLAN is now available for use on the switch. Now I need to go to everyone who needs to be a member of VLAN 10 and assign their port to be VLAN 10. So I'm going to go to the configuration mode and say interface fast Ethernet 02, which is this port outside in yellow right here. I'm going to say switch port mode access. Well, no fair, we haven't talked about the difference between access and trunk ports yet. Access port goes to host machines like employee PCs. Trunk ports usually go to another switch. We'll cover that a little bit later. And then I'm going to give the command switch port access VLAN 10, and that's going to assign VLAN 10 to that port. Now, as a convenience to you, if you don't do this part first and you do this part, it will automatically create VLAN 10 if you have not yet created it. So when you guys came in person and did the lab and you assigned that all those switch ports to VLAN 99 and it said VLAN 99 hasn't been created yet, I'm going to go ahead and create it for you as a convenience. So if you assign an interface to a VLAN that doesn't exist, he'll do it for you. He'll create the new LAN for you as a convenience. So we're manually assigning this. We're going to a command line interface and we're assigning ports to it. There is a thing that's beyond the scope of CCNA called a VLAN membership policy server, which is a server that you have to buy. It's iron, you have to buy it. And it will configure some dynamic VLAN stuff for you. But that's a CCNP topic. We don't have to worry about that. Now let's configure a range of ports. We did this in the first lab. So I want ports 1 through 10 outlined in yellow and blue on the diagram to be in VLAN 10. So I'm going to say interface range fast Ethernet 1 through 10. Then I'm going to say switch port mode access just to make sure they're access that goes to individual host machines, not a switch to switch link. And switch port access VLAN 10. If I had not yet created 10, it would have created it for me. And then I'm going to go to this Ethernet, the gigabit Ethernet port over here, and I'm going to do the same thing for him. So interface gigabit 01, switch port 1 access VLAN 10. Okay, so all the blue ports have been assigned now to VLAN 10. They can all talk to each other. Okay, what about the VLAN 20 guys, the guys that are in the red? So I'm going to do the same thing. I'm going to say VLAN 20. It'll create it for me. I'm going to give it the name Sales Department. And I'm going to say interface range 13 through 22. Notice he hasn't done these 23 and 24 here. I think he's saving them for a telephone. Switch port mode access VLAN 20. And then the gigabit port here, that takes care of that. Okay, so we've assigned our Human Resources Department and our Sales Department has all been assigned to proper ports. Now, I don't know if any of you guys have ever, I don't want to insult anybody. If you ever worked for a Human Resources Department, they tend to be pretty paranoid about all their human resources data because they have a lot of privacy rules that they need to comply with. And I joke that the human resources department, people that work for human resources are the people who failed finance. Well, if they had passed finance, they'd be in the finance department making big bucks. So the human resources department are set up for ports 1 through 10. The sales department people are set up through ports 13 through 22. We've got a couple of ports left over for telephones we're going to use later. And all the people in the HR department in the blue are given the IP address of 192.168.10 as their network. And everybody in the human resources department, or rather in the sales department, which are in red, are going to be 192.168.20. There's no communication yet between these two departments because we haven't put the router in there. We're not going to be able to do that until next week. So now let's do a show VLAN. The command show VLAN brief. Trim some of that garbage off the screen. If you do show VLAN, you get a whole page of garbage. So now we can see that the ports that have been assigned to VLAN 10, 1 through 10, the ports have been assigned to VLAN 20, 13 through 22. There's still some ports left over in the default VLAN, 11, 12, 23, and 24, because we're going to use those for telephones later. They're going to get their own voice VLAN. Now, our management VLAN. He is using the command interface VLAN 1 and giving it an IP address. We did this in the first lab. We didn't give it this IP address, but we gave it a similar address so that we could telnet into it. So how can we manage the switch? We can come in through telnet, which is, the problem with telnet is that it's all clear and unencrypted traffic. And so if someone's running Wireshark, some wire sniffer, packet sniffer product, they can see your name and password. So the alternative to telnet is secure shell SSH. That encrypts everything. It uses a public-private key pair. Nobody can see anything because they don't have your public and private keys. We can also use a web browsing. There's a little built-in, cute little built-in web server that's in the switch. And you can log into that web server from your desktop PC and do some management of the switch. It gives you a cute little picture of the switch and shows you which ports are light up and stuff like that. Also, we have simple network management protocol, which we'll see later. So management VLAN is what the IT people are going to use. Okay, we're not going to put our users on the management VLAN. Now, it's a good practice to not have it on VLAN 1 because of this. The VLAN 1 is stuck and we can't really modify it much. We're normally going to put it on another VLAN. And typically in the Cisco Network and Academy labs, we use VLAN 99. Okay, he says a native VLAN is assigned to a trunking port. That's so confusing. What the heck does that mean? So normally when we create different VLANs on a switch and we connect this switch to a second switch, we don't want a separate wire for each broadcast domain for each VLAN. We want to use one wire that conveys all that traffic back and forth. And to do that, we're going to need to tag the Ethernet frames with a numeric identifier which says, oh, this is an Ethernet frame that belongs in VLAN 10 or VLAN 20. So when it gets to the second switch, it sends it to the right ports. The native VLAN, you can have only one native VLAN in case you're using an old hub or something. And that's by default, it's going to be VLAN 1. We're going to change it typically to that VLAN 99 that we use for our management VLAN. And we'll get more about that later. Now, what about our telephones? Remember back in our fundamentals class, we talked about voice over IP traffic. It doesn't need a whole bunch of bandwidth. It does very little bandwidth, 10K or so is fine. However, it needs very little delay or latency. If it gets too much latency, it starts sounding like a Walmart prepaid phone. It's very bad quality. So as long as we can have good latency, less than about 150 milliseconds is about 1/7 of a second. You notice when you're on a cell phone call, the other side is typically delayed from your side. So it just requires a small amount of bandwidth and fairly low amount of latency. And let's put it on its own VLAN. So this voice traffic isn't encumbered or doesn't affect any of the other networks that are present on our company system. So VLAN 1 is our default VLAN for Cisco Discovery Protocol and so forth. We're going to abandon that. We're going to only use it for that. We're not going to place any ports on it. VLAN 10 is our human resources VLAN. VLAN 20 was our sales VLAN. How about we use VLAN 100 as our voice VLAN for our Cisco telephones? There are other companies besides Cisco that make voice over IP telephones. You don't have to use Cisco. But most companies that buy Cisco devices use all Cisco. Maybe he's going to use VLAN 155 for the management VLAN. And VLAN 199 is the garbage VLAN that no company servers are available on. And he's moved the native VLAN to VLAN 200. So a trunking cable, this black thing that connects our two switches together, it's a point-to-point link. It's just another Ethernet cable that plugs the two switches together. But instead of it being an access port, which can be only assigned to one VLAN, we're going to allow it to commingle all of these VLANs on one wire. And the word trunking comes from the telephone company. If you ever watch these British television shows that come on Channel 13, they talk about, the detective says, oh, we went to the phone company and he made a trunk call. And that's their term for a long distance call. So if I run a long distance wire between Dallas and Fort Worth, I want to be able to carry more than one phone conversation over that one wire. It's wasteful to use one wire for one phone conversation. So the phone company developed technology back in the 50s that could carry 24 voice calls over one wire. So trunk cables, when we connect them between switches, can carry multiple VLAN traffic between one switch and another switch. And we're going to do that by tagging it. The telephone company tagged the voice traffic. Each of the 24 voice traffics over a T1 line was tagged to be that particular voice traffic. So when it got back to the other, from Dallas to Fort Worth, it would be split to that phone call and not somebody else's phone call. So there are a couple of standards for here, and the more common standard, the 802.1q, the 802.3 Ethernet, 802.11 Wi-Fi. These are some standards, open standards that have been developed. 802.1q is a standard for trunking between two switches. Cisco had another one that was proprietary to Cisco, only worked with Cisco devices, called Interswitch Link, or ISL. We ain't gonna use that. Our switches won't even support it. So Cisco is promoting open standard stuff. Later on we'll get the OSPF routing protocol. That's an open standard routing protocol. So, this looks kind of technical here. So here we have our standard Ethernet frame. To review, the destination MAC address, the 48-bit MAC address, is the first part of the frame. Then the source MAC address, who transmitted the traffic, is there. Then there's a type length field, which indicates what type of upper layer data is in this Ethernet frame, and like an IPv4 packet, or an IPv6 packet, or an ARP request, or a Novell NetWare, or an AppleTalk, could be anything. And then at the end of the Ethernet frame, there's this frame check sequence that the receiving workstation can check to make sure that none of the bits have been messed up. He'll do his own calculation to the frame check sequence, and if it's different from what he heard on the wire, he'll say bogus. He'll drop the data. So we're going to take our fireman's axe and we're going to chop this frame in half, and we're going to insert a tag. And this tag is going to have the numeric ID of what is the VLAN ID that this Ethernet frame came from. Workstations cannot understand tagging. It has to be untagged before it goes back to the workstation. So the tag is added by the switch before it goes over the trunk link. And when it gets to the second switch, he removes the tag before he transmits it out to that other PC or that server on the second switch, because PCs can't understand tag frames. They'll look at it and say, it's a bogus Ethernet frame, I'm dropping it. So it's only from switch to switch communication. And as we see in the next chapter, when we bring in a router to communicate between our 2 or 3 VLANs, the router Ethernet port can be configured to understand the tagging, because he's got to configure between VLAN 10 and VLAN 20. Nothing confusing about that, right? Okay, so the native VLAN, some older devices like hubs do not understand tagging. So every switch has got to have a native VLAN. By default, it's going to be number 1. Now you can change it, and in our labs, we're typically going to change it to VLAN 99, our management VLAN, and we'll make that the native VLAN. Now, when you connect 2 switches together and you have configured the first switch and you change the native VLAN to 99, immediately the 2 switches are going to start to bitch at each other, saying, our VLAN IDs don't match. One's 1 and one's 99. And as soon as you go to the second switch and you configure it to be native VLAN 99, the error will stop. The coughing stopped. The native VLAN must be the same on both ends. Otherwise, you'll get incessant error messages. So we're going to change it to some VLAN other than VLAN 1. Control traffic, like Cisco Discovery Protocol, is always still going to be over VLAN 1. So by default, on a switch that has not been configured, all 26 ports are assigned to VLAN 1 on both switches. I'm going to plug the two switches together with an Ethernet cable. The light's going to light up. It's also VLAN 1. Now, if I want to use multiple VLANs, and I don't want to use a separate wire for each one, I want to use one fast piece of fiber optic cable between these two switches. I don't want to have to use, what do we got here, 6 VLANs? I don't want to have to use 6 fiber optic cables and waste 6 ports on all these switches. So I'm going to configure one port of the switch to be the trunking port on both ends and plug it together. And I can share over that super fast fiber optic cable, I can share all the traffic between the two company buildings or the 2 floors of the building. Here's the commands for this. So we need to configure the fast Ethernet 01 port. We need to configure the fast Ethernet 01 port of both switches to be trunking ports. They both got to be configured to be trunking ports. If I leave one trunking, leave the other one access, no communication takes place. So I'm going to go to switch 1, this one right here. I'm going to go to interface fast Ethernet 01. Now remember, it was assigned to VLAN 10. We don't want it to go to an employee desktop PC anymore. We want it to go to the other switch that we've added. So I did switch port access VLAN 10. Most iOS commands can be reversed by simply repeating the command and putting no in front of it. So no switch port access VLAN 10. Now on some switches, you may need to use this command switch port trunk encapsulation .1Q because some old Cisco switches also supported the ISL interswitch link. On our switches, you don't need to do that because they only have .1Q. But if you get other switches, they might have that command, and he won't. The reason we have to do that is he won't accept this command until he's sure what encapsulation type it is. We only going to use .1Q. So on our switches in the lab and in the packet tracer in the 2960, you don't need to do this command. It's by default already. Now I'm going to give the command switch port mode trunk. It's no longer an access port that goes to a single host machine. It's a commingled cable that goes to another switch, or maybe a router, that has a bunch of VLANs all mixed together, but they're tagged so I can tell which ones belong to which. Okay, now we got to go to switch 2 over here. We got to repeat this process. So we go to port 1 and we make it a switch port. That's minimum configuration. Now the two switches are trunking to each other. And with one, economically, with one cable between the two switches, no matter how many VLANs we have on these switches. Now our switches only have 24 ports, but you can get switches with 1,000 ports on them. So you want all that traffic to go over one wire. So now when we look at switch 1, we do the show VLAN command. Remember those 2 ports, the 4 ports we left active? We left on VLAN 1. We're going to put a phone on them later. They're still on the default VLAN number 1. So HR is in their bank of 10 and sales is in their bank of 10. What happened to fast Ethernet port 1? We typed show VLAN and 1 is nowhere. Well, when you change a port from an access port to a trunking port, it's no longer, show VLAN only shows access ports that are assigned to individual VLANs. So every physical single port on a switch can either be an access port, any port number you decide, any VLAN number you decide, or it can be a trunking port, which is normally intended to go to another switch or to a router. So there's no way to see which ports are trunking ports except you can see what, well, it's not in here anymore. There's another command, show interface trunk, that'll show us where it is. Now here's an example of I go to switch 1 and I say switch port trunk native VLAN 200. Immediately I start getting these red messages. They're red in the print here. They're gonna pop up like every 5 seconds on your switches, both switches, until I go to the second switch and I create it on this one, and then the error messages will stop. Oh, that's the end of that. That's the end of that. Okay, hang on just a second. I'm going to pop over to the second PowerPoint. Okay, and this is the official part here, and we've skipped the first part because I already covered it with the better pictures. So we talked about VLAN ranges. Our Catalyst 2960 switches can support quite a number of VLANs. You'll probably never need that many. I had a couple of guys here from UTA about 15 years ago in our Cisco Networking Academy, and they told me that UTA has 160 VLANs, and UTA is a pretty big school. So I don't think most businesses would need 1,000 or 4,000 of them. So when you create a VLAN, it's stored in the VLAN.dat file. You go to the global configuration mode. Oops, turn on the pencil. You go to the global configuration mode. You create the VLAN, VLAN 10. You create the name HR. Now, you don't have to do this first, remember. You can simply go to the individual interface port and assign it to be VLAN 10. If you haven't created VLAN 10 yet, it'll go ahead and create it for you as a courtesy. So if a student PC was going to be in VLAN 20, we would normally, the student PC is plugged into port 18 of switch 1, and we would go to switch 1, do config T, VLAN 20, name student, then type the N command to back out or Control Z. If you do not give a name to it, you get the default name. So if you can name it later, you don't have to do it right then. If you don't name the VLAN, if you create a VLAN 20, the default name is VLAN 0020. To each individual interface. The general syntax here was we go to configure terminal, we say interface FA01, 02, what the number is. Make sure it's not a trunking port, say switch port mode access. Make sure it's an access port. Again, access ports go to individual employee or student PCs. Trunking ports go to other switches or routers. Then we're going to give the command, switch port access VLAN 10, 20, 30, 99, whatever we're supposed to do. And that assigns that particular port to that VLAN. So let's see, we're going to assign the VLAN to the port interface, and then the end device will use the IP address information for that. So he's created a VLAN 20. It's going to port 18, which goes to the student here. Config terminal, interface FA018, switch port mode access, switch port access VLAN 20, and they made that VLAN ID corresponded to the third octet of the IP address. So that means when you troubleshoot this stuff later, it's one less thing to try to confuse you. And we'll use this later on in the next chapter also when we configure the router. We're going to make the numbers add up. Now, what about telephones? So inside each Cisco telephone is a miniature 3-port switch. Inside this little Cisco telephone here is a miniature 3-port switch. One port goes to the plug in the wall that goes eventually to port 18 on that switch 3. The other plug goes to the teacher or student's computer that's in the office or his classroom. And then the third port goes to the telephone itself. So what this purpose of this 3-port switch is, he wants to pass VLAN 20 traffic to the student, and he wants to pass the telephone traffic to the telephone. So the little 3-port switch on the telephone does that for you. He actually communicates with the switch via Cisco Discovery Protocol and figures out what VLAN he's supposed to use, and then he switches to that. So that's done by the people that configure the telephone. And configuring the telephone is sort of beyond the scope of CCNA. Quality of service for telephones is beyond the scope of this course. We're going to look at quality of service in a later 8-week course. So we want to create and name both the voice and data VLANs. In this case, they decided to use VLAN 150 is for Cisco voice over IP telephone traffic, and VLAN 20 is going to be the data to and from the computer itself. This quality of service command, we'll use that later. Don't worry about that for today. Now let's check. So like Reagan said, trust but verify. How can we check to make sure? I can type show VLAN summary and see the number of VLANs I've created right here. I can type show interface VLAN 20 and see that VLAN 20 is up and up. I can type show VLAN and see a whole page of extra garbage. I can type show VLAN brief like they did in the last slide, and you can just see that particular information. I can type show VLAN for one particular one and zoom in on that one as well. Now let's say I want to change the port from one port to another. I want to change a physical port number, in this case port number 18, and I want him to be assigned to a different VLAN. Say, for example, that the person that was plugged into that, whose PC was plugged into that particular port number, changed job function and moved to a different department. Someone else moved into there. So I have to change the port number. So I can re-enter the switchboard access. I can change it back to VLAN number 1. I can type no switchboard access VLAN, and it goes back to VLAN 1. Or if I say maybe I needed to be in VLAN 20 instead of VLAN 10, I can just say switchboard access VLAN 20, and that will change it. Want to use him. So when you delete a VLAN, you should move all the ports that were assigned to that VLAN to a different VLAN if you want them to still be in use. Now you could use that on a switch port in the closet that was no one was plugged into to prevent someone from walking in the closet and plugging in and try to get stuff, our so-called garbage VLAN. Okay, so when we want to get rid of all the VLANs, like we're done with our lab, of course, we're going to do erase start and do the reload command. But before we do the reload command, if we've done any type of labs where we created VLANs, we need to get rid of that. The full syntax is delete / VLAN .. You can simply type delete VLAN .. and then press enter 3 times, and it asks you, do you want to do this? Do you really, really want to do this? And then it will delete the VLAN .. file. And then once you type the reload command, you also must do the erase start to get rid of the startup configuration. Then when you restore it, you restore it to factory default, you can erase the startup configuration command, delete the VLAN .. file, and reload the device. Now, if you're doing a lab in class with me, you can just erase the startup configuration and delete the VLAN file. You don't have to reload it if you don't want to waste time, because it takes 5 minutes. When I turn the racks off and turn them back on again, it'll be reloaded. It'll be a factory fresh device at that point in time. Now let's look at more about trunking. So we're going to configure some trunking cables. So the trunks carry all the traffic for all VLANs. So to do this, I'm going to go to the configuration mode. I'm going to go to the particular interface, and I think in our lab we're using FA0/1. I'm going to say switch port mode trunk. Now remember this command, switch port trunk native VLAN 99 or whatever the lab says. When you do it on both switches, you'll get annoying error messages. Oh, here's a new command we haven't talked about yet. Switch port trunk allowed VLANs. You can trim which VLANs are allowed to be on a trunk. So in this case, we're going to have VLANs 10, 20, and 30. Our purple VLAN is going to be for the faculty and staff. The students will be in the blue, and the guests will go into the greenish one here. And they're plugged into different ports on the switch. Then port 01 of switch 1 goes to port 01 of switch 2. So the faculty that are in VLAN 10, they have a 10 in their IP address. The students that are in VLAN 20 have a 20 in their IP address. The students that are or the people that are in the guest VLANs have a 30. So this is assuming we're using a 2960 switch using 802.1q tagging, which is what we're using in our laboratory. And this, you pick the 2960 switch on packet tracer, do that. Now remember from the last frame, if it was a different switch that had layer 3 functionality into it, we might have to use that encapsulation command, but we won't need to do that either in our packet tracer exercises or if you come in and do the real lab. So let's verify the trunk configuration. I'm going to type the command show interfaces FA01 switch port, and it tells me it's trunking using the standard .1Q, which is recommended as an open standard. So I type show interface F01 switch port. It shows me it's trunking. It shows me it's operational. .1Q, and we've changed the native VLAN to 99. That's going to be our management VLAN. So we're not filtering VLANs. All VLANs are enabled. Now let's reset the trunk to the default state. We want all VLANs to be allowed to pass traffic, and we want the native VLAN to be VLAN number 1. So we're going to say no switch port trunk allowed VLAN, no switch port trunk native VLAN. If we have previously defined only certain trunks are allowed, this removes it. If we previously changed the native VLAN from, say, the default 1 to 99, it will put it back. Normally, all iOS commands can be reversed by repeating the command and putting the no in front of them. And that'll put it back to the native state. Now let's reset the wire to, I don't want it to be a trunking port. I want it to be an access port now. I'm going to use the command, I want switch port mode trunk. Now I'm going to say switch port mode access. That changes it back. Now if we do show interfaces FA01 switch port, it's an access port. Access port goes to a PC or a printer or a server or something of that nature. Trunking ports only usually go from a switch to switch or from a switch to a router. Now, dynamic trunking protocol. You guys remember, it's getting the David Letterman show, a late night TV show. They had a thing called Will It Sink? And they threw stuff into like a little tank of water, and they made bets beforehand. Will it float or will it sink? I call this will it trunk. If you plug two Cisco switches together, will they automatically trunk up to each other? Or will you have to manually enter the commands? Now, history. Cisco used to configure all of their switches so that when you plug two switches together, they would automatically trunk up. Because when you plug two switches together with an Ethernet cable, did not God intend that to be a trunking connection? And he would bring them up. However, they have changed their mind. Now, I told you before they changed their mind, they programmed the switches to be cut through and have fast performance. They changed their minds and they configured all the switches now by default to be store and forward. If you want to be high performance cut through, you can configure it yourself. Well, they did the same thing with this. So this dynamic trunking protocol is proprietary to Cisco. And what it is on 2960 switches, it's on. And our older 2950 switches, we've got some stored away in the next classroom. We're not using them right now. They had a slightly different method. So dynamic auto was on by default. I can turn this off if I want to. But what happens if you plug two of our 2960 switches together, they will not trunk. Now, if you say switch port mode trunk on one of them, the other one will obediently trunk right up. So this is a function of what is the dynamic mode. Our switches are dynamic auto. There's another thing called dynamic desirable. The old 2950 switches were dynamic desirable, and they would plug them together. They would trunk right up. So here are the four possibilities that a port can be configured. Access port. That goes to host machines like employee, student PCs, servers, printers. Not trunking. Never trunk. I could make it a trunking port. I could say switch port mode trunk. It's a trunking port, and I configured it to be that way. And as my personal preference is, I do not want no automatic configuration thing to do something for me. I want to be in control. I'm going to say switch port mode trunk, unconditionally trunk, or unconditionally be an access port. However, out of the box, our 2960 switches come as dynamic auto, which means it will trunk up if the neighboring interface he's plugged into, that switch has two, if it's desirable mode or someone said trunking on it, it'll automatically trunk up. So you can configure this on the machine yourself. My personal preference is switch port mode access, switch port mode trunk. Now in the lab, they're going to have you use dynamic desirable to prove that two switches can automatically trunk up to each other without you having to do something, because normally they have the right kind of idea here. Normally, when you plug a wire between one switch and another switch, you normally want it to be trunking so that you can share all the different VLANs and have them tagged in that particular trunking port. So this chart shows what happens. Will it sync, like Letterman said? Will it trunk? So if one switch is trunking and the other is dynamic auto or dynamic desirable, we will get a trunking connection. What if one port is enabled as an access port and another port is enabled as a trunking port? What do we get? We get a big fat nothing. They either both have to be trunking, and when I say they're both ports on the two switches, they're plugged together by one Ethernet cable, they either have to be both trunking somehow or both access somehow if you want communication between the two of them. We can verify this. We can type show DTP mode. It'll show us the status for that particular one. Now, hang loose a second. I'm going to pull up my packet tracer and do a little illustration here. Oh, let's see. Share, application, entire screen, share, and we should get packet tracer here in a second. Okay, so what I've done here is I've configured, let me move the mouse here, get the mouse action. Okay, here we go. So I've got two switches connected together. Default configuration, there's no configuration on these switches whatsoever. I have placed two PCs in there. I have configured them to have IP addresses. So if you float over it, it'll tell you. Very, very focused. There we go. So we can see that this first PC is 192.168.10.10. We can see that the second PC is 192.168.10.11. Now let's look at the default configuration of the switch. You see that all the port numbers are assigned to VLAN 1 by default, no configuration. So port 1 is up because it goes to the second switch. Port 6 is up because it goes to PCA. Let's look at the second switch. Totally unconfigured, no configuration. Port 1 is up because it goes back to the first switch. Port 18 is up because it goes to the second PC. Okay, so should I be able to ping between these two host machines? Well, absolutely. Everything's the default VLAN number 1. We have full connectivity between the two devices. So I should, in theory, be able to type ping 192.168.10.11, which is the IP address of the second PC, and it works. Okay, so we have full IP connectivity, full network connectivity between these two devices. Okay, now then, let's go to the first PC. Go to the command line interface, and I'll make it a little bigger so it's easy. And what I want to do is let me go to the privilege exec mode and do a show VLAN. And we can see that, oh, it scrolled up top of the screen. And maybe if I make it a little bigger here, there we go. So we see all the ports are assigned, all ports 1 through 24, and the 2 gigabit ports are assigned to VLAN number 1. The default VLAN, no configuration on the switch yet. I'm going to create a VLAN 10. I'll go to the configuration mode. Let's say VLAN 10. And I'm going to go to interface fast Ethernet 0/6 and say switch port access VLAN 10. And that port is now assigned to VLAN 10. Oh, how do we know? Well, like if I do a show VLAN 10, port number 6 is in VLAN 10. All the other ones have been unaffected there. Now, what if I type this command again? The ping is not working. And the reason the ping is not working, well, there's 2 reasons. First of all, the red light on there, the port has to change back to the green port. Okay, he did that. But notice the port changed back to the green port. That's spanning tree protocol. We'll get that later. I'm not getting connectivity. Well, we know the IP addresses are proper on the 2 PCs because we just pinged them a second ago. But if I float over here, I can see that port 6 is assigned to VLAN 10. Port 18 on the other switch is still assigned to VLAN 1. Well, what if I go to the second switch and go to the CLI? Oh, get back here, you. And let's go to the global configuration mode and go to port F0/18. Say switch port mode access VLAN 18. Oops. I'm sorry about switch port, access, VLAN. I'll expand. I didn't use tab completion. There we go. And notice this time I didn't create VLAN 18. I'm sorry, I meant to be VLAN. I meant to be VLAN 10. Sorry. Let me do that again. Okay, so now let's do a show VLAN. Show VLAN. There's my 18. Pay no attention to my 18. I did that by mistake. VLAN 10. Port 18 is now sent to VLAN 10. However, if we go to PCB and try to ping PCA, it's not going to work. And here's the reason why. I'll go back here. That port 1 between switch A and switch B, it's up and up, but it's still only assigned to VLAN 1. The two PCs are in VLAN 10. The only communication between the switches that's possible at this moment is VLAN 1 traffic. What should I do to those two ports so that they can be trunking and carry all the information back and forth? Maybe that'll fix the problem where we can communicate back and forth. Okay, so I'll go through the configuration mode and interface fast Ethernet 0/1 and say switch port mode trunk. And he didn't give this. I don't know why he didn't just give the command in the lesson, but it's show interface trunking. We can see that port 1 is trunking now. If I do a show VLAN, port 1's gone. It was taken away from the access port. You see it's missing, only 2 is there. And I'll go ahead and go to switch B and do the same thing. So we'll go to the configuration mode, interface, fast Ethernet, 0/1, switch port, mode. All right. And let's wait for that red lamp to go out. That's the it takes about 30 to 50 seconds. And then we should be able to ping back and forth between the two devices. Okay, so let's see. I'm going to go back to PCA. Try to ping PCB. Oh, look, it's working. The light turned green. It's working. Okay, so what's happened is the pinging traffic from PCA, when entered switch 1, it was tagged as being a member of VLAN 10. It progressed to the second switch. The second switch untagged it and only shouted out those ports that were assigned to VLAN 10, port 18. PCB heard the ping request, he replied to it. So we set up our VLAN, we set up our tracking port between the two devices, and we set up our two host machines to be a member of the same VLAN, and they can communicate with each other. Now, later on in another course, we're going to go in between these two devices. We're going to put a router in there. So the two devices are, one's in VLAN 10, one's in VLAN 20. They should be able to talk to each other. Okay. Unshare. Share. Where's my... Did it go away? Where the heck did it go here? Oh, I think it had become unmaximized. Hold on, share, application. Okay, so we have covered all the information on the module 3. And then Thursday, in-person lab opportunity, we'll come and do lab 3.4.6. And for you guys that want to do this remotely, I will tape pretty much the whole extent of the lab on the real Cisco equipment in the lab, but the packet tracer part is pretty well implemented. It'll work with that as well. Okay, guys, hang loose. I'm going to stop the recording.